Hello, welcome back to my series of videos where I do the Everybody Codes Challenge from 2025 many months after it was posted. I'm going to start this video tackling Quest 8. Before we start, a few things a little different. Number one, I have this timer right here that I'll start when I start Quest 8 so I can look at it and hopefully keep myself from running too long on the video. Then also I have changed my basic golang boilerplate code, so let's take a look at that first before we start the timer and open up Quest 8. So first off, so my basic, the main change about this is that I'm going to make the main function very short, and I'm going to put each problem in its own little function, like this. Also, because this is Quest 8, I should update the little boilerplate there to match. Okay, let's get going with the actual problem. Okay, before we do anything, start the timer. Quest 8. The rest of yours. Okay, Veronica is obsessed with the dragon duck. Dragon ducks. Yeah, okay. Now, skill is definitely solving puzzles. Side is the adult human. Young dragon ducks are usually on the side of the larger ducks. This puzzle seemed designed specifically for you to go stronger. Okay, the artwork referred to string art. To create such a wooden board, tiny nails, very long piece of thread. First, then you handle it. Sequences. Okay, assuming we only have 8 nails, it looks like this. Specific sequence of numbers. First, assuming you have 32 nails, construct string art according to the given nails sequence. Count how many times the thread passes through the exact center of the circle. So, if we had only 8 nails, then okay, so I think it's just count the things, see which ones have stuff on the, see which ones have stuff exactly 16 higher or lower than the start point, and you're done. Okay. Spot string scanner.text strings.split spot string comma for spot underscore comma spot range spots. Okay, and then crossings 0, return crossings, spot num dot a to I spot if bottom plus 16 equals p spot, or spot num minus 16 equals p spot. Crossings plus plus p spot equals spot num. Okay, did I download this? I don't think I did. Oh, I already did. Oh well. Let's see, where's my PowerShell window? Move. Go run quest 8, 57. 57. Da-da-da. Yay! Oh man, almost 5 minutes. Very large string art projects require additional stabilization across the threads. We tie a knot. Even if several threads cross at exactly the same point, we tie a separate knot with each of them individually. 256. Construct a string out. Knots would be needed to complete the whole thing. Okay, so eight nails. So we have one knot, 1, 2, 3 knots, 4, 5 knots, 6, 7 knots, just 3 knots. Okay, so every time I do this, I basically have to say how many of the previous line crossings do I cross. Okay. Now I want to check out how long are we talking here. Okay, we have a decent number. Okay, and basically these are going to, you cross a path if you have something that has one end in and one end out. Yeah. Okay. Update my main function to call number 2, problem 2. Okay, and then struct int make line seg 0. Okay, and now p Yes. Okay, so it is on one side of the thing if it is equal to neither dot and greater than exactly one of the dots. Yes. Yes, okay. Spot is equal to 0. All right, and these are numbered from 1 up. Okay. Okay, so if p spot not equals 0, then prefix append line set. Okay, so first here, I'm going to do that in a moment. 0 line seg p spot spot num. Okay, now for this, I do for seg underscore comma seg colon equals range presegs easy reject spot reject spot equals seg dot a or spot equal not spot spot num. You know what? Seg.b, I'm gonna rename something. Rename symbol to spot stir. Rename symbol to spot. Or p spot equals seg dot a or p spot equals seg dot b. If easy reject, continue, then if okay, and then spot inside a not equal okay, so this means it is greater than exactly one of them here. P spot greater than seg.a not equal to p spot p spot greater than seg.b. Okay, then if spot inside is not equal to p spot inside, crossings plus plus. Okay, that should do it. see if I got it right, or if I need to go back and rethink, and maybe there's some corner case I forgot. I don't. Yay! Okay. The art of string art is adapted to create symbols with magical properties. Shockwave. 2 nails on the circle. The more threads cut, the greater the effect of the spell. Best striked. Example based on the following notes. Striking between nails 6 and 1 would cut only 2 threads. Would cut 7 threads. Okay, so we have the thread that we are on ourselves. 1. Okay, how would that cut 7 threads? Hold up. Four threads. Okay, so between those, so you don't count the ones at the end. 1, 1, 2, 3. So 1, 3, and 2. Yes, okay, so we also cut that thread if it's there. So if the thread is there, then we cut it. And for everything else, we have to obey. So if the thread is actually there, then we cut it. For everything else, we have to obey the rules that we had before. Okay. So let's go back here. Add part 3 boilerplate. I'm thinking that next time I will also have problem 1, problem 2, and problem 3 set up to, improve the boilerplate. So we're not going to do this. Okay. Now, what I'm going to do is max crossings. Okay, max crossings, and now, right, for spot 1, spot 256, spot B, spot A plus 1, spot B 256, spot B plus plus. And now I'm going to say, crossings, colon equals 0, do some max crossings equals max crossings crossings. Okay, and now okay, now I'm going to actually change this to make sure that they are always using the max. Always using the min one and then using the max. And then this is spot A. Okay, and actually I'm going to surround this here so that P spot goes out of scope. If spot A spot dot A spot B equals spot dot B. This is seg. Okay. Okay. And spot A is always the smaller one? Yes, okay. Oh, I forgot to download my okay, now let me go back and make sure that okay, I did use input 3. Yes, I did use input 3 when I came up with that answer. So what was that answer again? 2797. Yep, okay, yeah, let's go and do another quest. But before we go open another quest, I'm going to set up my boilerplate for quest 9. Quest 9, main.go, paste, and what I'm going to do here, quest 9, quest 9, quest 9. And this will just return. Okay. Okay, and that's what all 3 of my problems are going to look like to start with. Okay. Okay, quest 9, ready to go. Yep, okay, let us Let us begin quest 9. Quest 9, Grand Center of Knowledge. Find him at his desk. Thaddeus. Your talent is solving puzzles. You will regret perfect timing. Your skills. Okay. Thaddeus discusses. Each individual has its unique DNA identifier, of course, according to each of its scales. ATCG. Child always comes from one of the parents. That means. Okay. Child. 1, 2, and 3. Ignore those numbers. Scales of two parents and their child. Find the child's scale and calculate the degree of similarity. $18, $23. Find the child. Okay, so we're going to be given 3 scales. We've got to find the child's scale and find the similarity. Okay. Okay, there's is there a way to initialize a construct EPS? Okay, the answer is no. Okay, so what is this? This is \d plus colon ACTG, right, ACTG plus scales. For right now, right now we're just going to store these as string arrays. For scanner.scan, parts parser.find string, find string submatch of scanner.text, scales.append, parts 2. Okay. if scales 3 panic okay. Okay, so then we test 1 as the child, then 2 as the child, then 3 as the child. For dx, range 3, for index, comma, not genome, base, range, scales, bracket, child idx, if base, if scales, bracket, child idx plus 1% 3, match 1, match 2, int var. IDX is not equal to base, and wait, why is that? Oh, is base a rune? Match 1 equals 0, match 2 equals 0, break. Then if match 1 greater than 0, match 2 good catch, compiler. Okay, break. Match 2 plus. Okay. Yep, this looks correct to me. Okay, did I get my? Yes, I did in fact download my stuff. I just hadn't moved it over. 6630. Yay! Okay, 10 minutes. Okay. 100. Shows each child. Connections between children and parents. Calculate the sum of all degrees of similarity involved. Okay, so I think what I'm going to do, shoot, I have to determine, so I don't think I want to take all triplicate pairs, do I? First, let's download the data. Download the data. Move the data over. Okay. So actually, the similarity, the index doesn't really matter, right? Like, okay, but it doesn't matter which one is 1 and which, yeah, so I'm just going to do that. That's fine. I don't need to parse the ID. Okay, so for every thing there, I have to say, is this pair of parents compatible? Okay, so I could compute the is it really that bad? I mean, I'm only doing like 5,000 comparisons, you know, per thing. Yeah, okay. Okay, so what do I have to return again? The sum of all similarity degrees. Okay, so yeah. Okay. Actually, this is idx1 0, idx1 plus len scales, idx1 plus plus, this is idx2, idx2 less than len scales, idx2 plus plus, okay, found parents equals false. Okay, found parents equals false. Range child scales idx1 idx2 idx1 idx2 actually we don't ever need this. Simsum plus equals 1, 2. And then this becomes 4 underscore. Okay, here, I do that. Okay. Okay. Now, do we need to, we only care about the degrees of similarity. Okay. So we only care about the degrees of similarity. Here, let's run our quest 9. Didn't get exactly 3 scales. Right. Don't care about that in part 2. Okay, not as scary as I thought. Aw, man. Okay, so it is a 6-digit number, but it's not that 6-digit number. So let me try this. me do a I'm going to go up here into input. Samp. And now I go over here and I do input everybody codes quiz 9 underscore p2 underscore samp 3616. Okay, and that says that instead. So what I'm going to do is here in problem 2, I'm going to print line p2 debug child idx. So I have to go back and restore this. Child idx dx match 1 match 2 match 1 times match 2. And actually I'm going to do child idx plus 1 just because. Okay, and now oh, interesting. So I was expecting most of these to have, I was expecting the parents to be zeros, but apparently it's finding stuff for all of them. Ah, okay, wait, hold up. If child idx if continue. Right. I had thought about, oh, gotta remember to skip the children. 1, 2, 4, 5. Is that the thing? Yeah, 1, 2, 4, 5. Okay. So now let's run regular quest 9 without that, and good. Yay! Okay. So yeah, I forgot the. I had thought about this, making sure we skip the child one before I set up the loops, but I got into it and just forgot it. Okay. Part 3, Nerdmaster. Any chain of connections. Children may have parents from entirely different generations. Moreover, even siblings can lay eggs. No limit to how the family joins. Biggest family. Okay. The second family has more members, and the sum of their scale numbers. Okay, we just have to count the sum of the scale numbers. So for this one, we don't care about degree of similarity. We only care about scale number sum, and we basically want to unify the two groups. Gotcha. Okay. Okay, so I'm going to start with number 2. But then I will change it, obviously. Okay, so make sure I download the data and copy it over. Okay, now check, are these again 1 to 500? They are. Yeah, I'll parse the things. So make scales become a map from int to string, and instead parts is that. Strconv.a to I etui parts 1, and then scales bracket scale num equals parts 2. Okay. Okay, so now what I'm going to do okay. You know what? I gotta go through everything, and I gotta attach them together. I gotta go through all the pairs. Okay, I'm gonna, I know I've just turned this into a map, but I'm gonna be a little bit evil and use the fact that I know that the map is from 1 to length of map. Oh well. Okay, so then what do we do? Then what we need is we need so what do we have? We have connections. Okay, and what is a connection? A connection says that we have a child and 2 parents, and they are all part of the same house. Okay, so so every connection will be a thing of 3. Connections make 0 okay, every connection will have three values in it. And then, so first I go through and I make the connections. Okay, so boom, and then if match 1 and then connections, append connections of idx1, idx2, child idx. Then, okay, so after I've done that, I have all of my connections made. Now, family num make, so going to be a map from int to int, and I'm going to start out with for range scales, family num bracket key key. Now, for, okay, done false, for not done, done equals true, for connection, connection, range connections, family min equals min of family num of connection bracket 0 connection family num of connection bracket 1 family num of connection bracket 2. If we're not all there at the minimum, then we do done equals false, and copy, paste, zero, okay, and then max fam 0, max fam for and then we have something here for fam size, make map int fam scale tote, make map int int for snum famnum range family num fam size famnum plus plus fam scale tote famnum plus equals fam scale tote plus equals snum, and then if fam size bracket fam num greater than max fam size, return okay. Taking advantage here of the fact that in Go, maps always initialize to 0. Okay, this should work, and I'm at just over an hour working on all of this. Now, okay, here we go. Index out of run, range error 0 with length 0. Okay, where did I go wrong? Oh. Okay. Yay! Good. Okay, so took me just over an hour to do 2 quizzes. Or 2 quests. That's good for 1 video. And right, I will see you next time. Oh. Okay, so I'm not really happy with how fast this runs, or rather how fast it doesn't run. So maybe there's a way to get this to run a little faster. Yeah, 1.6 seconds. I generally like to get these quests to run at under a second. So I'll probably have some optimization to do at a later time. I'm not going to do that right now. And I'm going to rip this out of there. But there you go. And now git add dot quests 8 and 9. And I will see you next time. Thank you for watching to the end if you did. If you didn't, you're not hearing this anyway. I will put stuff on the end cards up for everything in my series of I do the 2025 the 2025 challenge of Everybody Codes and general Everybody Codes stuff. Okay. Bye.